So this is lecture video 5 on pulmonary function testing. Again, I would reiterate these lectures are just an overview, but I would definitely, if you want more comprehensive lecture, view the Zoom videos that are in the content section, or try to make the Zoom classes that are being held during your normal class time, because this unit can get a little confusing, and so it's kind of nice if we have face-to-face interaction during this unit. But next we're going to determine percent predicted. When we're looking at PFTs, we're going to want to put everything in percent predicted, because then you can say it's normal if it's within 80 to 100% predictive, it's a mild disease if it's 60 to 80% of predicted, or it's a moderate disease if it's 40 to 60% of predicted, and a severe disease if it's less than 40% of predicted. The only exception is FEV1. FEV1% is 70 to 75% is normal for FEV1%. So to calculate percent of predicted, you take your observed value divided by your predicted value times 100. So to do a couple examples of these, if we have a parameter such as forced vital capacity, get my pen up here. So if we have a forced vital capacity, and based on the patient's age, height, and gender, we would say that they're predicted, let's say this patient's predicted forced vital capacity is 5.28 liters. And when they actually performed the PFT, they achieved 4.11 liters. And we want to know what their percent of predicted is. So we are going to take their actual value of 4.11, divide it by the predicted value of 5.28, and then multiply that by 100 to put it into a percentage. So if you do that, if you take 4.11 divided by 5.28 and then multiply it by 100, you get about 78% of predicted. So this person's forced vital capacity is not considered normal because it doesn't fall within the 80 to 100% of predicted. All right, so let's do another one of those. Oops. All right, so we're going to do another one of these, calculating percent of predicted. So let's say we've talked a little bit about FEV1. Now you want to make sure that you're keeping your FEV1 and FEV1%. They're not the same thing. So when we talk about FEV1, we're just talking about the forced expiratory volume in 1 second. The FEV1% is the forced vital capacity, or forced FEV1, forced expiratory volume in 1 second, divided by the total forced vital capacity. So the two of them are different, so you want to make sure that you keep those separate as we're going through this. But let's say we have an FEV1, we have a predicted value, which again, based on the patient's age, gender, and height, is going to give them a predicted FEV1. And then let's say that is 3.24 liters. And their actual value, or when they did the PFT, they actually achieved 2.43 liters. So again, we're going to take our observed value, or our actual value of 2.43 liters, divide it by a predicted value of 3.24, multiply by 100 to put it in a percentage, and you get about 75% of predicted. So again, that would not fall within the normal range of 80 to 100% of predicted. One thing I did want to point out is FEV1, when it's listed on a PFT report or the reports that we're going to look at as we're going more through the unit, the FEV1% is already in a percentage. 1%. That's a really bad. Let me erase that and redo it. So FEV1% is already in a percentage, so it will show an actual and a predicted. Let's switch those around so we keep it consistent. FEV1%. So they're going to give you a predicted value for that patient and an actual value. Predicted value is pretty much always going to be between 70 and 70%. There might not even be a number there. But let's say their predicted value was 75%. And then their actual value is 59%. These you do not have to calculate into percent predicted because they're already in percentages for you, so you don't have to calculate that. So if this person's FEV1, when they actually did the PFT, was 59%, that would not fall within the normal limits. Again, the normal limits for FEV1% are 70 to 75%. So the actual for this one, this person achieved a 59%, so they would not be considered normal. In fact, they would be in the moderate obstructive disease category because low FEV1% tell us that it's an obstructive disease. Calculating pack years, that's another thing that we may calculate when you're in the PFT lab. And pack years are the packs per day that somebody smoked times the years smoked. So if somebody smoked 2 packs per year, or per day, sorry, and they tell you they've been smoking for 40 years, you're going to take their packs per day of 2 times 40, and they have pack years of 80 years. So smoking 2 packs per day for 40 years is about the same as smoking cigarettes for 80 years. So of course, the higher number of pack years, the more likely they are to have a lung disease. And there's that error message again. So we'll go ahead and stop this video.